Okay, in the last lesson we studied arithmetic sequences, which were ordered lists of numbers. In this lesson we study arithmetic series, which you'll see the difference there. You might notice that we jumped from section 9.2 to 9.4. That's quite common to present these in this way. It wouldn't be wrong to have gone directly through, but I was already organized like this. I'm going to keep it this way. So we know what we mean by arithmetic. We're just extending this to this new concept of a series. So a series is the sum of a sequence. And here are a couple examples. Sequence 6, 9, 12, 15, 18. Series 6 plus 9 plus 12 plus 15 plus 18. Okay. They said that the sum is 60. Well, if you have a finite arithmetic series, you can evaluate it. Basically, if it says evaluate the series, that means find the sum. So this is the sum of 60. Now, notice the difference between this sequence and this sequence, right? And the difference is the dot, dot, dot at the end, which means this is infinite. So you can see the pattern, right? The pattern is a common difference of 4. You keep adding 4 to get to the next term. And so the next term would be 19 and 23 and 27, dot, dot, dot. It's just going to keep going infinitely, right? If I turn that into a series, right, an infinite sequence turns into an infinite series. Do you think you can evaluate an infinite series, at least an infinite arithmetic series? And the answer is no, because the sum will keep changing. Every next term you add on, you get a different sum. So there is no sum. You can't evaluate an infinite arithmetic series. Okay. Right, so we have a formula for the sum of an arithmetic series, and here's the formula. If you did the copy work that I assigned for extra credit at the beginning, you've already copied this down, but the capital S with a subscript of n means this is going to be the sum of n terms, right? There's n terms in a sequence, so n terms in the series. We're going to add them up. Capital S stands for sum. Okay, the n is the number of terms, right? N is the number of terms. A1, we know, is the first term. Now the AN is the nth term. But you might want to think of it like it's the last term in the sequence, because sometimes the number of terms that you're adding up, this n doesn't necessarily match the actual term in the sequence that you're going after. So just be cautious about the way we use these n's here. But the way I think of it is like this. N is the number of terms. A1 is the first term, no matter if it has a subscript of 1 or not. AN is the last term, no matter if it has the same subscript as this n right here or this n right here. We'll see how that works. So what is the sum of the first of the even integers from 2 to 100? Okay, well, let's see what these is. This is the kind of thing that you might not understand immediately, but you should. You should. You know, a fair number of you are 10th and 11th graders. You could be taking the SAT, and in the SAT, they're going to use a word like integer, like you know what it means, right? It's not going to be a quiz question. It's just going to be, you know, find the integer that solves this equation. So they need you to know what it means to be an integer. Okay, even integers from 2 to 100. That would mean the even counting numbers from 2 to 100. 2 plus 4 plus 6 plus plus 98 plus 100. Could you write down all those numbers and just add them up? Absolutely. Again, that's what I would call a brute force method. But remember our formula here. Sn equals n over 2 times a1 plus an. we need to know three things, right? The first term is easy, right? The 2 is the first term. The last term is 100. That'll go there. Now, how many terms are there going to be? If it's just the even numbers from 2 to 100, and hopefully that's not too big of a stretch to see that that's actually 50, right? There's 100 integers from 1 to 100. If you just take the even numbers, that's 50. So actually we are taking the sum of 50 terms, and it should be 50 divided by 2 times 2 plus 100. So this is 25 times 102. And you should put that in your calculator to figure it out. I should be able to do this quicker than I'm going to do it. I think it's like 250, 300. Let's see, might have that wrong. 2,550, I think. 25 times 102. 0, 1, 5, 0, 4, 0, 2. So that's 0, 5, 5, 2. So 2550. So try to do the same thing with this one. You can see the first and the last term. I've actually given you the number of terms. That was not in the problem, and could make that a more difficult problem if you didn't know that, but my goal is to not make you figure that part out. So go ahead and hit pause, get out the formula, and plug in everything, and see if you can find the sum of this finite arithmetic series. So again, the formula is Sn equals n over 2 times a1 plus an. So S, we are adding up 20 terms, so it should be 20 over 2 times the first term of 4 plus the last term of 99. So S20 equals 10 times 103, which is 1030. Okay, now that brings, my guess is those first two slides weren't that tough. There's a formula to know, but actually you're going to be given the formula. You just have to know how to use it. But this is the part where, besides the notation of a sub n and a sub n minus 1 with recursive formulas and all that, which could be hard to understand, you might have a hard time with this one too. This is called sigma notation or the summation notation. And it's the capital Greek letter sigma, which is a way to express a series. Not just an arithmetic series, but a series. Okay. Now, you can see the parts in the series. The n is the index of a series. It equals a lower limit, 3, and that upper limit is on the top, 108. This n squared is a formula it's the explicit formula for the nth term in this sequence, meaning this is the formula for an, which we went over last class when we just first introduced sequences. Okay, now what does this mean? It means that you're gonna plug in 3 here and get 3 squared. Then you're gonna plug in 4 and get 4 squared. And you're gonna keep adding the terms, 3 squared plus 4 squared plus 5 squared plus, and you're gonna keep going until you get to 108. So you're gonna end up with plus 107 squared plus 108 squared. That is what we mean by, that is how the summation or sigma notation works. Right? It just means take this formula and evaluate it for this number, and then keep adding as you evaluate for the next number, and the next number, and the next number, until you get all the way up to this number. That's the last term. Now, we're not actually adding this one up, just showing you that that's how this summation notation works. So what is the summation notation for this series? Okay. So again, we need to be able to plug in for n equals, and now if you have to make the summation notation, if you notice on the last one, it started at 3, but generally, you're just going to start yours at 1. No matter what, it's going to be 1. And what else do you need to know then? You're going to need to know like how many terms in this sequence, because that's going to be the number on the top of this thing. And then you're going to need to know the formula that goes in front. Well, if you notice the pattern here, what kind of a sequence is this? Does it look, can you see the pattern of what's going on? The answer is it's arithmetic. It looks like we keep adding 7 to each one. Well, we have a formula for that, right? A1 plus n minus 1 times d. So let's make our formula here. -5 plus n minus 1 times 7. All right, that's the formula. Now, how do we know what number goes on the top here? Well, you would have to know, when does this formula give you that value? Right? If I say -5 plus n minus 1 times 7 equals 268, I need to solve that for n. Add 5. That'd be 273. Divide by 7. See, 7 goes into 24, or 27 3 times. And there'd be 6 left over, 63, 39. So n equals 40. Now, you normally wouldn't see that as the answer in the textbook because it's not simplified. I mean, we could simplify that. This is -5 plus 7n minus 7, 7n minus 12. So we could have written the whole thing a little more easily as n equals 1 to 40 of 7n minus 12. But it's up to you. Just remember, the way we get to this formula is from that, which we learned in the last lesson. And remember, this is a section which is all about arithmetic series. So we have every reason to think that these probably fit that pattern. Right, how about this one? Again, we're gonna start it with the sum of n equals 1. And we have to figure out the formula that goes here and how many terms are in the sequence. Okay, well, the formula that goes here should be the first term, 500, plus n minus 1 times the common difference, which looks like -10. So that is the formula. Okay, now we need to know what number goes on top. Okay, we'll set your formula. Equal to 10. Then solve. Okay, minus 500. N minus 1 times -10 equals -490. Divide by -10. N minus 1 equals positive 49. Add 1. So this is 50. Again, if I wanted to simplify it, I could simplify this formula by doing 500 times plus -10n, so minus 10n. -1 times -10 is plus 10. So that's 510 minus 10n. Okay, now multiple choice. What is the summation notation for this series right here? Okay, so what do we need to match up? we need to be able to match up the formula. Is it generating the right terms? And the number of terms, which starts at whatever the lower limit is, go to the upper limit. So let's see. Let's plug in the lower value and see if we get 7. 4 times 1 plus 3 is 7. That's good. So all of these, okay, so that would have worked for this one and this one. It doesn't work. Well, actually, it would work for this one, right? If I plugged in a 1, I would get a 7. That works. So they all work for the lower limit. Try for the upper limit. If I plug in the last number here, I should get 207. So what is 4 times 51 plus 3 is 204 plus 3, which is 207. Okay, that's correct. So actually this one matched both the lower limit and the upper limit, so that's good. Okay, let's see what would have been wrong if we did this one. This one would have gotten us 4 times 50 plus 3. That's 203, so it's not that one. 7 times 50 is 350, not that one. 7 times 51 is 357, not that one. So the answer is this. Again, all we did is just plug in the lower limit and see if you get 7. Plug in the upper limit, see if you get 207. Okay, summation notation and linear functions. So if the explicit formula for the nth term is a linear function of n, then it's arithmetic. We see that kind of thing. Well, you see it here. This is what they're talking about. If this formula is linear, meaning it's similar to like y equals mx plus b, then it's arithmetic, and that is. Go back to the ones like this. I mean, we know both of these are arithmetic. We can see it in the pattern. But look at the formula. One simplified. This is like saying mx plus b. The one before it. mx plus b. That means it's arithmetic. So what is the sum of the series written in summation notation from 1 to 70? Okay, well, we only have one formula here. Okay. The formula is this, Sn equals n over 2 times a1, the first term, plus an, the last term. So the first term is what you get if you plug in 1, right? So a1 equals 5 times 1 plus 3, which is 8. All right, an is going to be what you get if you plug in, if you plug in the last term. So that'll be the an is 5 times 70 plus 3, which is 350 plus 3, 353. Now, how do you find the number of terms? In your mind, you might, well, if it starts counting at 1 and it ends at 70, then how many terms is that? That's 70. So we're taking the sum of 70 terms. It should be 70 over 2 plus the first term of 8, the last term of 353. And then you do the math. 35 times 353, that's 361, equals. And I am not going to do long multiplication, even though I could. I'm going to plug it in my calculator, which you can't see, times 361. It looks like it's 12,635. Okay, what is the sum of this one? Okay, well notice I didn't make enough of a point of this, but again, this followed the pattern, mx plus b. That's why we could use this formula. Right? this is definitely not mx plus b. So you can't use that formula. And that's the only formula that we've got. So basically, you're just going to have to plug in 7 times. Start at 1 and go to 7. Right? The first term should be 1 minus 1 squared. The next term should be 2 minus 1 squared. 3 minus 1 squared. 4 minus 1 squared. 5 minus 1 squared. 6 minus 1 squared. And finally, 7 minus 1 squared. So this is 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. Right? That's the last term. And now these are 0 plus 1 plus 4 plus 9 plus 16 plus 25 plus 36. So I mean, because this is not arithmetic, it's not linear, which means it's not an arithmetic series, we can't use our formula. You can only just plug it in and brute force it, right? So how much is this? It's 61, 77, 86, 91. Right? So try to do the same thing for this first one. Notice that this first one is definitely linear, mx plus b. So you can use this formula. So go ahead, hit pause. When you're done, hit play. Okay, so we can say right away, this is 40 terms. So that part is done. The first term we're going to get when we plug in 1. Let's see, so A1 equals 3 times 1 minus 8, which is negative 5. Right, the last term is what we get when we plug in 40. 3 times 40 minus 8 would be 120 minus 8, which is 112. Okay, so then that's it. It should be 20 times 107, which should be 214 with a 0 on the end. Okay, try the same thing with this. Well, again, this is going to be 1 because this formula is not linear. It's not arithmetic. You can't use the formula. All you can really do is just plug in for 1, 2, 3, 4. Right? Add them up. Brute force method. Hit pause. When you're done, hit play. So this should be 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third, which is 1 plus 8 plus 27 plus 64. And let's see, 80, these two make 91. 99 equals an even 100. So any summation can be evaluated using decimals. So we're going to go back and look at the ones that we already did, right? And open up Desmos. Okay, so here we go to Desmos. Oops, that was wrong. So where do you think we're going to find the summation notation in Desmos? Where do we find everything? Keyboard functions. Okay, and if you don't see it anywhere else, you look under miscellaneous. Do you see the Greek letter sigma that we understand to be summation notation? Yes, it's right there. Okay, so no, it's going to let us put everything that we need in here. If you remember, it was from 1 to 70, and I would recommend putting this in a formula. What was this? 5n plus 3. 5n plus 3. And the answer is 12,635. Okay, so, probably seems like, then why are we doing any of this stuff? Well, honestly, you could be taking this test, and I could be, I don't like to use the calculator or decimals. I'm not going to do that, but many teachers would. I mean, to just so we've at least addressed how this stuff works, I think is important. Right? You can see, remember, we did this one before. Right there. Same answer. Right? Again, this is one that we wouldn't have been able to do it with any of our formulas. It's got 50 terms. We're not going to generate 50 terms with this pattern here. We're just not. So at this point, you're definitely going to be using the calculators or Desmos. So go ahead and try to see if you can evaluate this one using Desmos. Hit pause. When you're done, hit play. And I will be going to Desmos. So go back, Greek letter sigma, 1 to 50, parentheses, n squared minus n, I believe. Let me go back. 1 to 50, n squared minus n. The answer is here, 41650. In fact, I'm going to even do this, if I can. So that is what it looks like in Desmos. And that is the end of arithmetic series. Okay, so we did arithmetic sequences, now we do arithmetic series. Next we're going to do geometric sequence, and then the last lesson will be geometric series, and that is this unit. And that is our homework.